All right. Hi, everyone. I am Luca. I'm a software engineer at ARM in the UK, and I've been contributing to the DPDK project and the new DTS ever since November 2023. So I'm rather new, actually, to DPDK in general. So today, I'm going to be showcasing how to write and run tests in the new DPDK test framework. But before we start doing that, there are some actual requirements and premises that need to be said. First of all, the new DTS, DPDK test suite, is a continuous work in progress. What that means effectively is that the API is subject to continuous changes while the project reaches maturity. If your developer API, if you're writing a test suite, things can easily change as we start merging new stuff, as the framework is very important, and there are stuff that are missing. Also, we've been following an incremental approach to the development of DTS, which means, for example, that if we are developing a test suite that requires to use a specific test PND command, and that command hasn't been implemented within the framework, then it means that we're going to add it in the specific spot, and eventually it's going to be merged, and the next people are going to use it. Also, DTS is meant to only test the implementation of physical devices within DPDK. And at the moment, our current objective is to use the test.pnd shell as testing interface as much as we can. Now, there are a couple of requirements in order to run DTS. We need two servers, or just one in loopback. The moment with a per port topology setup, this is a requirement only now. In the future, we're actually planning to support different port topologies. So we have one node, which we call system under test. This needs to be set up for the DPDK compilation from source. And then from the other side of the link, we need to have a traffic generator. At the moment, we only support SCAPI, and it's just for functional testing. And so that needs to be installed on the traffic generator server. Finally, passwordless sudos should be enabled for the SSH user that DTS will use, and also the public keys need to be set up on both servers as well. For this specific demonstration, we require a client machine with Docker installed, and for development, we actually recommend to use VS Code with the dev containers extension installed as well. But Docker is not a requirement, and neither is VS Code. But if you wanted to run Enveloper for DTS without Docker, at the moment you're required to have Python 3.10 and Poetry installed. Now you also need to configure DTS. The configuration is done in a YAML file. We actually have a sample under the DTS folder in the DPDK repository, which is conf.yaml, and basically this configuration file will have a field containing all the nodes that you want to test. So you will need to specify at least one assistant on the test node, one traffic generator node, with 2 ports each, because it needs to have 2 pairs of interconnected ports. And also, you need to specify test runs, which are effectively just your runtime configuration for DPDK and other stuff, and which has also these fields specific to this that can also be overridden using the command line arguments when running DTS. Now, we can just show quickly how to run hello world. We're not actually going to do a demonstration on the terminal. We're just going to go through slides. So the first thing you need to do in order to run hello world is that we need to build, in this case, a render image, which is actually it's just being used here for demonstration purposes only for the presentation, but we don't actually recommend to use it, as that's only meant for CI, so automation. But the process should be really very straightforward. Under the DS folder, there's a Docker file, so you can call Docker build and specify runner as target. And once this is successful, you basically have an image that contains the current version of DTS available to run. Also, since we want to run the hello world example, that means that in the conf.yaml, we want to specify hello world under the test suite under your test run, or you can, as I said earlier, you can use the command line argument to override this, and you can just pass test suite hello world, which will just run test hello world in this case, overriding everything else. Now, the working directory in the container is actually /dpk/DTS, so it stays at the root of the container. But the thing is that you're expected to mount your DPDK repository in the same folder, and also you're required to mount the SSH keys so that DTS can actually connect to those servers. And in this specific command line example, we are assuming that we are in the DTS folder, in the DPDK repository. And we are, as earlier specified already, we are showing hello world. And then we also have a snapshot. So here we provide basically just a tarball of the repository in its current state. So like git archive, and this file needs to be placed in the same folder as the DTS folder in this case, because it's the mounted volume. So that was pretty much it. It should be quite straightforward. That's the idea of it. We can just move to show how to write a test suite. So the first thing you want to do is, in this case, is to open the DDS folder, not the DPK one, in VS Code, in which case you should be automatically prompted to open this in a dev container. So that was actually very helpful and very straightforward, because you just press the button and it's going to automatically set up the whole environment, install the extensions that you're required to use for the development, such as MyPy. And once you're ready, the environment is set up, you can just open a new terminal. And the thing you need to do before proceeding is that you need to install the actual DTS dependencies using poetry install. And then you can actually use these dependencies and the DTS by entering the poetry shell. The main.py is effectively the entry point, and dash help is effectively, as you know, just the help page that shows you all the arguments that you can pass to DTS. Now, if you want to write a test suite, at the moment it's a bit bothersome, but we're working towards streamlining the process and make it easier. There are quite a few rules at the moment. So first thing, the file needs to be placed under the test folder under DTS. Also, the file also needs to be prefixed with test suite underline. And for example, if we have example underline suite, the test suite should be called test suite underline example underline suite.py. Also, the file needs to have a class which basically defines the test suite, and this class needs to inherit test suite, which is part of the framework. And you can see the import command here in the slide. Another requirement is that the class name needs to be prefixed with test, and then the test suite name that we use for the file name also needs to be specified, but in Pascal case or Apple Camel case. So as you can see here, an example, it should be test example suite, all capitalized. Also, this is the last thing, but it soon will not be will no longer be required, which is specifying your new test suite in the confiamo schema file, which is at the moment it's used for validating that your configuration file is correct. But we are actually removing this, so it shouldn't be a problem anymore. This is pretty much a diff to show you how to just create your file. Just pretty simple. Just start the example suite in the schema file, and then create your file, which is just a simple class. There's nothing else to add to this. But you'll want to add test cases. So how do we write test cases? Well, first of all, the test suite class has some hooks available, which are quite standard common practice in testing. So we have setup suite, setup test case, tear down test case, and tear down suite. Setup suite, of course, starts at the beginning of the test suite when it gets run. And so that's tear down suite at the very end, whereas the setup test case and tear down test case happens before and after running every single test case. Now, test cases need to be prefixed as well with test underline, but in the very near future, we're actually changing this, and it won't be a requirement anymore, but what will be required is using the decorator test, which will actually have configuration parameters for your test cases as well in the future. For example, if you have an all-course test case, this is effectively how you need to define it. So you also need to specify the types because we are trying to enforce stronger typing through static type checking in DTS as well. This is an example, quite straightforward. If you want to have a single core and an all-course test case for your test example suite, this is pretty much how you write that. Now, there are a few APIs available at the moment. The test suite class, which you inherit to create your test suite, actually has a few which should suit most of the cases. We have send packet capture, which the only thing that it does is that you provide the packet that you want to send to DPDK, And then on the other end, the traffic generator is going to capture all the packets it listens on its RX port. So basically what DPK will forward back. The capture works by using a timeout. So you can also specify the duration. You can change that. I think by default is 5, but I'm not 100% sure on that. So it's going to listen for 5 seconds, 1 second to all the packets that are incoming. So they can also be noise, like link layer packets and so on, in which case you will want to verify that later. We also have send packets and capture, which similarly, you can just pass a list of all the packets you wanted to send. And this one is interesting, the get expected packet. The idea of that is that it's going to take your packet and it's just going to swap the MAC addresses and AP addresses, or just add the correct ones so that you can actually match the receiving packets to the one you sent as from the DPDK perspective. Now we have a very simple verify method as well, which you just pass a condition. If that condition fails, then the test case fails, and the failure message that you specify will be returned instead. We also have verify packets, which effectively just take one. It takes one packet to be expected. Usually use this in conjunction with get expected packet, and then the list of received packets from, for example, send packet and capture. If this will only check, it will do a deep packet inspection. If your packet is in the list, then this succeeds. Otherwise, it will fail a test case. Finally, we also have match all packets. It takes a list of all the packets to expect, and you give it a list of all the received packets, and it's just gonna make sure, it's just gonna basically count if all the packets you expected are present in the received ones. If so, just passes, otherwise it fails. There are also a couple of objects which you can access, which is the object instance for the system on the test node and the traffic generator node, which you should be able to access all the configuration parameters and all that kind of stuff. You're going to ask how to write packets, and that's quite a normal question to ask. We have actually a generate random packets utility, which you can specify the number of packets you want to generate, the payload size you want your packets to be, and also the protocols to use. You can say, I want to use L3, I want to use L4, or for example, for L4, you can choose, I want to use UDP or TCP or even both, and it's just going to automatically pick randomly for every single packet it's going to generate. If you use L4 protocols, you also need to specify a ports range, so you can also automatically and randomly select a port for each packet from that range. The INTU value is mandatory, because that is just there to enforce that the payload size you specify is respected and won't break the system. If you don't want to generate random packets, you can just arbitrarily create your packet by using SCAPI constructs. Should be quite straightforward. What DTS adds to this is that you can just add the L2 and L3 layers empty. You don't need to specify anything else. And DTS will automatically fill this for you with the correct physical MAC addresses and some IP addresses, which are predefined in DTS. You can also, as mentioned earlier, we use the SPND shell a lot. So how to use the SPND shell, you can just import this from the framework again, and you can just call it. It is required that you specify the node instance for the system under test for this. And then you can pass to the actual function, to the class instance, you can pass all the arguments for the SPND shell as well. So you can actually customize that. And then after you enter in this with context, you have access to the shell, and you can send all the commands you want from the ones that are implemented, or access all the configuration. There are quite a few testpnd shells commands implemented at the moment, and these should be available in the documentation. And yet again, as I specified at the beginning, if there are missing ones, this should be implemented. You shouldn't just be using send command, which is what we provide. It's just a raw command where you can just give your string, like your command with all the arguments, and it's just going to send it. But ideally, you don't want to use this in your test suite. Please implement the command in the framework and use that one instead. Send command should only be used within the framework, ideally. Now, there are some further considerations that should be added to this. That was pretty much how to write a test suite. Don't have like, for example, a ready test suite. But there are quite a few in the repository at the moment that you can have a look at, like PMD buffer scatter. There's also Hello World, actually, which I showed start to run earlier. And I think OS UDP, but that's going to be dropped soon because that was just meant to be a test one. Now, there are some upcoming changes which means they are already out in the mailing list and they are be processed to be reviewed, and hopefully they're going to be merged soon. So we have an ability to skip the test suites and or cases by NIC capabilities. So for example, if your NIC doesn't support RX scatter for some reason, your test suite requires it, you can say this test suite or test case support needs this. And basically DTS is going to check at the beginning of the execution if this capability is available. If it's not, it's just going to automatically skip this test suite test case. It won't fail it. And you can just decorate your test case and test function to do this. Another thing we are providing is effectively adding a custom configuration per test suite. So if you want to have a special field for your test case, or you're testing the speed at which your port is set up, this variable changes for every single test run, you can just add this custom field, and you can change in your conf YAML so that you can personalize this on the go when you do it. And well, yet again, there are also more testpnd commands up there in the mailing list that are hopefully will be available to use soon. The future work that we plan on implementing, and well, in the future, I couldn't say near, maybe in the next year, will be the support for virtual machines and SRIOV, and also virtual function support. And importantly, performance testing, because at the moment we only support SCAPI, which is only used as a capturing traffic generator and for functional testing. So we plan to support some traffic generators which are more suitable for performance testing, like T-Rex or DPerf or DPDK packet gen, so that we can actually enable performance testing and enable DTS to do benchmarks. Apart from testpnd, we also plan on supporting compress dev, crypto dev, and other applications that DPDK has. Now, you can find a couple of resources which are really available there, which is the documentation page. You can find it just on the regular DPDK documentation under the tools section. There's DTS there at the bottom. Or you can also use the DTS dev Slack channel. This is basically frequented by the DTS maintainers and all the developers, and we are always going to be available there if you need help, if you want to ask questions, if you want to have some discussions, or just provide us with some feedback. Hopefully it's going to be good. And also now in DTS, I think this is the first month now, we're actually using it. We have our own DTS Next repository so that we can merge our stuff faster and be email faster. Now, before we move on to the Q&A, I would actually give a special thanks to Uri and Jeremy. These two people basically are the responsible for the biggest contributions to the framework of DTS in the past years. And unfortunately, they're leaving us this month, so they're no longer going to contribute to DTS. And also a very big mention to Patrick and Nick because they actually offered they offered to basically replace me in case I wasn't going to be able to do this virtual presentation today. So thank you very much for bearing with me. And thank you again, Patrick, for actually being on the stand and helping me with the Q&A as well. And another thank you for all the people that are working on DTS and are contributing to it.